So anyways, on this one, it says a square field is enlarged by adding 5 feet to the length and the width of the original field. If the area is 576 feet, what is the side length of the field? So we have a square, and a square is different than a rectangle because that means all the sides are the same, right? So if all the side lengths are the same, that means that this side length is equal to this side length. And so when we talk about the area of a rectangle, it's just the length times the width. But on a square, and that's what they said, a square field was enlarged by adding 5 feet to the length and the width because it has to be the same. We think of it as the side times the side, which is really the length times the length, okay? So what they're saying is this is the original field, all right? And then they're going to take that field and then they're going to make a bigger field. And they're going to increase it by 5. So this bigger field now is going to be S plus 5, and this would be S plus 5, okay? That's not S plus S, it's S plus 5. So in order to find the area of this thing, the area of this is equal to S plus 5 squared, right? I forgot to mention that way up here. S times S is S squared. So they said if the area of the field is enlarged and it is 576 feet, what is the side length of the original field? Oh, wow. So we got to go back and solve for S, basically. So I'm going to say that the area is 576 feet, and that's equal to S plus 5. And I realize my 5 looks like an S. So just like all the other problems, I'm just going to take the square root of this. When I do that, the square root of 576, turn on our handy dandy calculators. And I'll zoom in so you guys can see it. 576, right? So I'm going to hit second, and then the x squared button. That gives me my square root thing, and I'm going to say 576. What is that, 24? I don't need no calculator. All right, so this is 24. Now, technically, it's plus or minus 24, but in a couple of problems prior to this, we realized we're never going to have a negative side length. In this case, we could focus on what we call the principal root, right? When we take the square root of something, there's the principal root, which is the positive one. That's the one that we use most commonly in the real world. And then there's the other root, which is the negative one. So this is technically plus or minus 24, but in this case, we're only going to focus on the principal root. Well, that's equal to S plus 5, because when I take the square root of a square, I'm undoing the square. The square root undoes that process. So I've got S plus 5. I know that this is not easy to figure out or read because it looks like 5 plus 5 or S plus S. Mr. Adams is doing the best he can. But what I'm going to need to do is I need to subtract 5 from both sides. So when I subtract 5 from both sides, I get 19 is equal to S. So that is the original side length. So way up here, the original side length is 19. And then the new side length here is 24. Does that make sense? So I'll scroll down here so you can finish writing that down.